Fruit peels, long relegated to compost bins and food waste streams, are now being reevaluated through the lens of gut microbiome science. Emerging evidence supports the hypothesis that the dietary fibers in fruit peels, namely soluble types like pectin and insoluble types such as cellulose and hemicellulose, serve as potent prebiotic substrates. These fibers are not only more abundant in peels than in pulp, but also possess unique structural properties that influence their fermentability by gut microbiota. As a result, they may help shape microbial communities in ways that improve digestion, immunity, inflammation control, and even mental well-being through the gut-brain axis. Apple, banana, and citrus peels are leading examples of this fiber richness. Apple peels, for instance, provide approximately 2.4 grams of fiber per 100 grams, nearly half of the total fiber content of the whole fruit, despite accounting for a relatively small portion of the fruit by weight. Much of this is insoluble cellulose and hemicellulose, but apple peels also contain fermentable pectin, which selectively feeds beneficial bacteria such as bifidobacteria and lactobacillus. Banana peels are even more fiber-dense, containing up to 30% total fiber, dry weight, which includes lignin and resistant starches. Citrus peels, too, are noteworthy for their abundant and chemically diverse pectins, which form gels and slow digestion in the gut, increasing satiety and modulating glucose uptake. These natural compounds have been widely studied for their viscosity, fermentability, and ability to modulate the gut microbiota toward an anti-inflammatory profile. The fermentative action of gut bacteria on these fibers yields short-chain fatty acids, SCFAs, such as acetate, propionate, and butyrate, metabolites that have systemic effects on health. Butyrate, in particular, is a key fuel for colonocytes, supports the integrity of the intestinal lining, and has been shown to reduce colonic inflammation and oxidative stress. In vitro fermentation studies using isolated fruit peel fibers have demonstrated robust SCFA production, often exceeding that of commercial prebiotics like inulin when adjusted for fermentable mass. For instance, orange peel-derived pectin has been shown to increase butyrate and stimulate mucus production in animal models, enhancing the mucosal barrier and reducing pathogen adherence in the colon. These findings align well with the observed epidemiological correlations between high fruit fiber intake and reduced risk of gastrointestinal disorders, metabolic syndrome, and even certain cancers. The distinct ratio and molecular structure of soluble versus insoluble fiber in fruit peels play a critical role in determining their prebiotic potential. Soluble fibers like pectin and arabinogalactans tend to be more readily fermented and support microbial diversity, while insoluble fibers like lignin and cellulose add bulk and help regulate bowel movements. Fruit peels often offer a natural composite of both, making them ideal for modulating multiple aspects of digestive health. For example, dried mango and guava peels have been shown to contain highly functional fiber fractions capable of enhancing probiotic viability in fermented dairy products. This makes them promising candidates for incorporation into symbiotic formulations, products that combine probiotics and prebiotics to synergistically support the gut ecosystem. There is also growing interest in how peel fiber supplementation could influence gut microbiota composition in human trials. Preliminary animal studies suggest that diets enriched with fruit peel powders can increase microbial diversity, elevate SCFA production, and reduce markers of gut inflammation. Future research could involve controlled human trials comparing stool microbiome composition and metabolic markers after supplementation with different fruit peel fibers. Variables such as dose, processing method, e.g., freeze-dried versus heat-dried, and source fruit could be manipulated to optimize prebiotic efficacy. From a food technology standpoint, fruit peel fibers are remarkably versatile. They can be dried, milled into fine powders, and added to baked goods, beverages, cereals, and dietary supplements without significantly altering flavor or texture when properly formulated. This makes them ideal for functional food development aimed at improving digestive health, especially for populations with low fiber intake. In addition to their prebiotic role, these fibers can improve product texture, moisture retention, and shelf life, offering both nutritional and technological benefits. Importantly, the sustainability implications of using fruit peels as dietary fiber sources cannot be overstated. Globally, fruit processing generates millions of tons of peel waste annually. Converting this biomass into high-value prebiotic ingredients represents a circular economy strategy that addresses both nutrition and environmental goals. Industrial-scale extraction of pectin from citrus peels is already common, and similar methods can be adapted to other peels with high fiber content. Moreover, using peels as feedstock for microbiome-targeted products can reduce reliance on synthetic additives and promote the use of natural, whole food-based ingredients in wellness formulations. In conclusion, fruit peels offer a uniquely potent and sustainable source of prebiotic fibers that are often richer, more fermentable, and more bioactive than those found in fruit pulp. By modulating the gut microbiota, increasing SCFA production, and enhancing mucosal health, these fibers offer meaningful contributions to digestive and systemic health. As the microbiome becomes increasingly central to our understanding of nutrition and disease prevention, fruit peel fibers stand out as promising tools in both research and practical applications, representing a convergence of food science, health optimization, and environmental stewardship.